Enterprise software deployment operates under an unforgiving constraint. You have to push updates to thousands of servers continuously, but a single bad commit can take down the entire system. Scaling a codebase from a 5-person startup to a 50-plus developer enterprise requires a specific coordination strategy to avoid halting the deployment pipeline. To solve this, modern teams rely on a trunk-based philosophy. The rule is simple. The main branch serves as the immutable, always deployable source of truth. Instead of sequestering work in long-lived integration branches that inevitably cause massive merge conflicts, today's pipelines protect that main branch with strict automated quality gates and mandatory pull request reviews. At the enterprise level, version control operates as a highly calibrated risk management system designed specifically to maximize deployment velocity. Selecting how your team branches and merges code is an architectural decision. This 3D matrix shows the 3 constraints every architect must balance. On the x-axis, deployment speed. On the y-axis, risk management through quality gate complexity. And on the z-axis, team size capacity. Choosing a branching workflow means consciously engineering a trade-off. If you maximize for continuous speed, your capacity for complex manual quality gates shrinks. We can evaluate these trade-offs by analyzing 4 distinct models: GitHub Flow, feature branch, release branch, and the forking workflow. There is no universally perfect Git model. There is only the correct architectural choice for a specific organizational profile and its required compliance threshold. For cloud-native applications and microservices, the highest priority is continuous iteration. This illustrates GitHub Flow. A single, permanent main branch tracks forward constantly, prioritizing a direct path to production. A short-lived feature branch deviates for changes, undergoes a mandatory pull request, and upon automated success, merges back immediately. This model achieves maximum velocity, but it demands absolute, uncompromising trust in your automated continuous integration and deployment pipelines. Because branches exist only for hours or days, the cognitive overhead remains low, which natively prevents complex, tangled merge conflicts. GitHub Flow maximizes speed by minimizing branching complexity. It is optimal for rapid iteration, but highly risky for teams lacking robust automated testing to catch errors before they hit the mainline. If an organization operates on weekly or monthly release cycles, they typically require formal code reviews and clear audit trails. The feature branch workflow protects the main branch with multiple concurrent feature branches running parallel, completely isolated from one another. The pull request serves as a dedicated environment for peer review, architectural alignment, and staging deployments prior to integration. This systematic isolation allows multiple distinct teams to work simultaneously on different features without destabilizing the shared main codebase. The operational trade-off here is a naturally slower integration process created by manual review bottlenecks. Feature branching intentionally sacrifices absolute speed to create a mandatory audit trail and a human-verified quality gate prior to any code integration. Some enterprise products face strict quarterly release schedules, extensive compliance testing, and the need to coordinate multiple system components simultaneously. In the release branch workflow, a long-lived parallel line spawns from main for release preparation. Quality hardening and bug fixes occur on this locked-down branch, while future updates continue on main. Finally, the stabilized branch merges back and deploys. This structure brings severe operational costs, high cognitive overhead, significantly delayed feedback loops, and complex merge conflict resolutions when bringing those delayed changes back together. Release branching accepts an extremely slow deployment velocity in exchange for dedicated quality hardening and absolute compliance verification. When scaling to massive open-source projects or enterprise organizations integrating hundreds of external contractors, the risk profile changes entirely. You face a sprawling, decentralized network of contributors where absolute code security must be maintained against unauthorized modifications. Centralized version control models share a core vulnerability in this scenario. They require granting direct repository write access to unverified external contributors. The forking workflow creates a dual-layer security model isolating the canonical repository. Developers create a server-side fork, clone it locally, and push code to their personal fork. Integration relies on a pull request bridging to boundary, gated by strict maintainer oversight. The forking workflow establishes a dual-layer security architecture, enabling zero-trust collaboration across massive distributed organizations. Consider a crisis. A critical bug is reported in production, but your main branch already contains new, untested feature commits intended for a future release. Simply merging a fix into the current main branch and deploying it is a catastrophic failure. You would inadvertently release that untested feature code directly to your users. To execute this repair safely, branch from a semantic tag to isolate the historical state of the code running in production. Spawn a hotfix branch bypassing recent work. After applying the fix, deploy to production, then merge the fix forward into main. Because the main branch progressed while you were fixing the bug, you will likely need to resolve merge conflicts locally by pulling the latest changes from main into your feature branch. By leveraging lightweight branching, engineering teams can manipulate repository history. You protect the production environment during a crisis without halting parallel development. Bringing all these models together requires a final architectural decision. This comprehensive matrix compares our 4 workflows across team size, release frequency, and quality gate complexity. For applications requiring continuous deployment, GitHub Flow offers unmatched speed. If your team requires moderate cycles with formal reviews, the feature branch workflow strikes a balanced compromise. For organizations bound by strict quarterly compliance, release branching provides necessary stabilization. And for zero-trust environments with distributed teams, the forking workflow enforces absolute code isolation. Regardless of the chosen workflow, the ultimate directive remains the same. You must enforce strict quality gates to maintain a consistently deployable main branch. The architecture of a repository dictates the operational limits of an engineering organization. Workflow selection is the most critical foundational decision.